All right, so we're going to look at 7.5 homework. And this is, oh, wait, no, we already did 7.5. Oh, sorry, 7.6 homework. All right, so in the 7.6 homework, we are writing systems as matrices. So that's what we are going to look at first. In these first ones, you're literally just transferring the idea of a system of equations into a matrix. So what you need to do is just make sure that these are in the right order. So notice we have x, y, z equals constant, x, y, z equals constant, x, y, z equals constant. And that's what you need. And then we can just consider the first column like being the x's, second column being the y's, third column being the z's, and then the fourth will be the constants. So you're literally just filling these in. If one of them is missing, so like let's say this last equation here didn't have a y, we would just put a 0 there instead. Would be the coefficient. So you're just transferring your system of equations into a matrix. So same question. This one actually should have really been in the last section. This is just asking if it's okay to add these matrices together. Remember, in order to add two matrices, they have to be exactly the same order. So this is 4 by 4, and this one is also, oh, this one is 4 by 5. You see that? So we can't add these together. They have to be the exact same number of rows and number of columns. Because when you add matrices, you add the positions together. So 0 plus 4, -1 plus -3, 3 plus -1, -3 plus 3, and then, uh-oh, he doesn't have a fifth column like he does. So you cannot do this one. They're not the right size. So in this one, you're converting the other way. So this one has, they're giving us the matrix, and they want us to convert it back over to a system of equations. So it says up here that n was the first column. So this first column represents n's, the variable n. Second one is the variable x. Third one is the variable c. And then, of course, the constant on the other side. So the first one, oops, this first one represents the equation. You have 1n, 0 x's, 0 c's, and that equals 1. So in other words, n equals 1. This one is 0 n's, 1 x, 0 c's equals 5. So notice that just tells you that x is 5. And in the last one, we have 0 n's, we have 0 x's, we have 1 c, and it says this is -3. So in other words, c is -3. So you're just converting it back over to a system of equations. And then notice that these are not in that same order. So c was the column 3, that was -3. N was the first column. And then x is, so see, they're out of order. The x was second column, so x is 5. All right, let's see, what do we got next? That's the same thing we just did. Same as the first ones. Notice that this one is going to have, see, the first column is going to be 1, 3, -5. Second column is going to be 0, 1, 0. And the column is going to be 0, 0, 1. Or sorry, last column, third column. And then the last column is going to be those numbers. So, all right, let's see. This is just like that, the one we did a second ago. But notice this one doesn't tell you what the columns are. In general, it's always x, y, z, unless they say otherwise. So this one tells you that x is equal to -1. It tells you that y is equal to -3, and it tells you that z is equal to 2. All right, let's see. Here we are having to solve this system, and it wants me to solve it by using a matrix. So the idea is going to be to reduce the matrix down to reduced echelon form, and then we'll be able to go back and solve it. So the idea behind the echelon form, by putting it in that form, is that we want, well, let me write this down. There's my y's, my z's, and my constants. So here it is as a matrix. What we want is for this little triangle here, we want those to all be zeros. Okay, so that's going to be our goal. That way, the last one, or the last row, only has a z. This one has just a y and a z, and the top one has an x, y, z. So again, we want everybody in here to be a 0. Okay, so what we're going to do is use our elementary row operations to make that happen. I really should have changed the order of them here. Notice that first row, we could simplify that very quickly by just dividing everybody by -3. So really, we're going to multiply row 1 by -1/3 and get ourselves a new row 1. So dividing by -3. So that'd be a 2, a -3, a 2, and a 0. -2, 1, -3, -4, and -2, 3. Notice we didn't change any of the other rows, just the first one. All right, so now what we're going to do is we're going to use this to zero out the ones below it. And we do that by adding. And notice they're already opposite. We can literally just do row 1 plus row 2 to get ourselves a new row 2. But then we'll also do row 1 plus row 3 to get ourselves a new row 3. Okay. Notice we're not changing row 1. Not going to change him. So let's just add these. 2 plus -2 is 0. -3 plus 1. 2 plus -3. And 0 plus -4. Be a little careful here. It's easy to make a mistake, so I'm just going to double check that. -3 plus 1 is -2. 2 minus 3 is -1. 0 minus 4. Okay, so now top row and bottom row, add them together. That's our new third row. 2 minus 2, -3 plus 3. 2 minus 3, 0 minus 4. So here's our new matrix. And look, it's got all of the zeros right where we wanted them. So now the idea is going to be just to turn this back into equations from the bottom up. So looking at the bottom equation here, we're going to be able to find z pretty easily. So it says -z equals -4. Well, then z is 4. So look, we found z right off the bat. Now what we'll do is look at the second equation. So we did the last one. Now let's look at the second one. The second one says that -2y minus z, which we know is a 4, is equal to -4. So see, this is why you work from the bottom up. You'll find z, plug it into the next one and find y, plug both of those into the top and find x. So notice if we just add the 4 to the other side, -4, oh, we'll get 0. And then divide both sides by -2, so y must be 0. Now, back to so that was the second row. Now go to the top row. So the top row says that 2x minus 3y plus 2z equals 0. So that means that 2x plus 8 equals 0. So 2x equals -8. Therefore, x must be what? -4. And then remember, you can always check these. So if I were to plug these values in up here at the top, I'd get -6 times -4 is what? 24 plus 0 minus 24 equals 0. So see, it works in the first one. In the second one, well, I'm not going to do them all, but see, you can go back and plug them in and check. That would be 8 minus 12, which is -4, and 8, oh, minus 12 is also -4. So our answer here is going to be -404. So -404. Oops. Trying to be quick and use the tab button. So it looks good. Let's see. Let's look at this one now. And this one, we're going to do the same thing we did in the last one. So we're going to start, I'm wondering if maybe using a different one on the top would be easier, but yeah, let's just leave it, I guess. Oh, whoops. Darn it. Sorry about that. All right. So we're going to have -13x plus 8y plus, oh, whoops, sorry. I don't know what I'm doing. All right, -13, 8, 33, and 21. -4, -1, 24, and 3. 4, -2, -12, and -6. I think I wrote those down right. Let's see. -1, 33, 24, -12, 21, 3. Okay, so that looks good. So now remember what we want to try to do is we want these to be zeros. So we make those zeros by using the top position. So that's, you can write the equations down in any order. So I was going to write it a different way. It would have been easier to maybe put the bottom, to swap the bottom and top, which we can do. But I'm just going to stick with it like this. So I need to get a -13 and a -4 to be opposites of each other, which is not going to happen very regular. Let's see. So I need a -13 to become a +4. So I am going to multiply by, how about -4 over 13. So if I multiply the first row by this and add it to the second row, that will give me a new second row. So see, I'm trying to figure out what do I multiply this by so that it's equal to a 4. So see, that would be -4/13. Now the reason I want it to be 4 is so that, see, when I add them together, I'll get 0, because 4 plus -4 is 0. So now for the last one, I'm actually going to do a +4/13 times row 1. I'll add him to row 3, and that will give me my new row 3. So the last one was a little bit simpler, but notice we're not changing the first row. We're just changing these second two. So I'm just going to use my calculator to do this. So I'm just going to do -4 over 13 times row 1. So times -13. Then I'm going to add that to -4, and I get a 0, which is, well, we knew we were going to get a 0. So -4 over 13 times 8, I'm going to add that to the -1 in the second row. And that's going to give me -45 over 13. All right, now I'm going to do -4 over 13 times 33, and I'm going to add that to the 24 in the second row. And that's going to be 180 over 13. All right, now I'm going to do 21 times -4 over 13. And I'm going to add that to the 3 from the second row. And that's going to give me -45 over 13. Now we're going to do the last row. So I'm going to be doing +4/13 times the first row, adding it to the last row. So 4 over 13 times -13, add the 4, and I get 0, which is good because that's what we wanted. 4 over 13 times 8, and then add that to the -2 in the last row. And that gives me 6/13. All right, now I'm going to do 4/13 times that 33 and add that to the -12 in the last row. And that gives me -24 over 13. And lastly, 4 over 13 times that 21. And I'm going to add that to the negative 6 in the last row. And that gives me a 6 over 13. All right, now notice both of those second rows are just big messes now. Why don't we just multiply them both by 13 so that they're not fractions anymore? I think that would make things look a lot better. So let's just do, and actually we still need this one to be a 0, but we'll have to do that in a second. So let's just multiply 13 times row 2 to get a nice new row 2. And we'll do 13 times row 3 and get a nice row 3. Notice all that's going to do is eliminate all those fractions. So now we've got negative 13, 8, 33, 21, 0. Oh, you know, we could have done better than that. Look at there. The 13 will get rid of the bottoms, but 45 and 180. Yeah, you guys, look at this. If I multiply by 13 over 45, and I do this one, 13 over 6, it's going to like greatly reduce this. So look at the first one. If I multiply this times this, 13's cancel, 45's cancel, I get a negative 1. Pretty nice. Now multiply this one times the 13 over 45. 13's cancel, and 180 divided by 45 is just 4. And then when you do the last ones, you'll get a negative 1 again. So now for the last one, if I multiply here, I get a 1. If I multiply the next ones, so now I'm here multiplying these two, 13's cancel, and you'll get a negative 4. And then multiply the last ones, and you'll get a 1. So now remember, we still need this one to be a 0. So I can just add row 2 plus row 3. They're already opposites, and get a new row 3. So again, we're not changing the top one. We're not changing the second one. But I'm adding these two together. 0 plus 0 is 0. Negative 1 plus 1 is 0. 4 plus negative 4, 0. Negative 1 plus 1, 0. All right, so now when we go and convert this back over to solve, notice that last equation, which is what we're going to start with, the last equation just says 0 equals 0. So from the last equation down here, we get 0 equals 0. What this means is that z is equal to, well, z, whatever it wants to be. That says whatever, I swear. Whatever it wants. And notice right here in the directions, it says to put everything in terms of z. Well, this is telling me z can be whatever it wants. So when we come over to here to put in our answer, we are literally just going to put a z right there. So looking at the second equation, this tells me negative y plus 4z's are going to equal negative 1. Well, z is allowed to be whatever it wants to be. So let's solve this for y real quick. So if I move the y to the right and I move the 1 to the left, I'm going to get that y is equal to 4z plus 1. So that's actually what we're going to put in for y, 4z plus 1. You see, this has an infinite number of solutions because z can be whatever it wants. So now we're still plugging in. So see, you're plugging in a z for z. We're going to be plugging in a 4z plus 1 for y. So let's go back to the first row. Remember how we kind of work backwards here. So according to the first row, negative 13x plus 8y, which is 4z plus 1, plus 33z, which is, well, z, this should be equal to 21. So again, we're trying to solve this for x. Let's just distribute this through. That's 32z plus 8 plus 33z equals 21. So negative 13x, that's going to be what, a 55z? And then we can move the 8 to the other side. Let's see, 21 minus 8 is just what, 13? Oh, I can't add, you guys. 32 plus 33 is 65. Again, we're trying to solve this for x. So we just need to move this to the other side. And then we're going to divide. So divide everybody by -13. And we'll get a -1. So again, we're just dividing everybody by -13. And that actually goes in even. That's a 5 right there at the end. So plus 5z. So we have our x is going to be -1 plus 5z. Our y is going to be 4z plus 1. And our z is going to be, well, z, which is kind of cool. So this one had an infinite number. So there's our z. There's our, I wrote it the other way, but, and then our -1 plus 5z. So, or no, I guess I did. I don't know what. So we've got our answers. Now, again, this one had an infinite number of solutions. You can always tell if there's an infinite number because you get just like a true statement. In this case, we got 0 equals 0. And that was in our z row. So that just means z can be whatever the heck it wants. All right, let's see. So that's like we've already done a couple of those. That's just converting this back over to an equation. So it's going to be 1x, 0y, 0z, 400, etc. Same thing. Just a lot of redundancy here. All right, so in this one, they just want me to reduce it like we were doing a moment ago. And remember, we had a 3 by 3 earlier. So it was like, or actually it was, I'm just writing the alphabet here. So remember, when we were reducing it, row reducing it, we needed for these to all be zeros. Well, this one's only a 2 by 2, or sorry, a 2 by 3. So if you think about that diagonal, oh, it only includes one thing. So we just have to turn that 5 into a 0. That's all we've got to do here. So it's all about the rows. The first row should have a leading number, whatever. The second row should begin with 0, then a number. The third row, 0, 0, then a number, etc. You're kind of taking this little bottom triangle and making it zeros. So how are we going to get rid of that 5? Well, we'll use the 1 to get rid of it. So what would I multiply 1 by so that it equals a -5? Well, I multiply it by -5. So I'm going to multiply first row by -5 and add it to the second row to get a new second row. I'm not touching the first row. He's fine. But in the second row, and if you want, do a little scratch work over here. So -5 times row 1, what would that look like? It'd be -5, -10, -20. You see, just multiply that first row by -5. And now we're going to add that to the second row, which is 5, -4, -2. We're going to add these together, and that's what we're putting here. So that's a 0, that's a -14, and that's a -22. And so now it's in reduced form because the lower diagonal is zeros, okay? So there it is, what we just came up with. All right, so that was your 7-6 homework.